The rise in demand around the world for highly efficient pipeline infrastructures has led to a rapid development in horizontal directional drilling equipment, commonly known as HDD. As a technology and market leader, Heron Connect offers the entire range of mechanized tunneling technology for all geological conditions. Heron Connect HDD equipment is used worldwide for the trenchless installation of pipelines for gas, oil, water, sewage, power cables, and communication services. The Heron Connect design of HDD equipment, shown in this animation, is a smart solution for various drilling lengths and all kinds of pipeline diameters. For alluvial soils, as well as for rocky conditions and other stable geologies, HDD is the right method to install a prefabricated pipeline fast and cost-effectively underneath obstacles. The principal working method is easy to explain. From an entry point on one side of the crossing, a steerable drill is pushed through the ground to the exit point on the other side of the obstacle. The pilot bore is then enlarged in one or more reaming passes until the borehole has reached the desired diameter. In the final step, the prepared product pipe is pulled by the drill rig into the bentonite-filled hole and then placed safely in the ground. Heron Connect designs and manufactures drill rigs with maximum pull forces between 600 and 6,000 kilonewton, with corresponding torque ranges from 35 kilonewton-meter up to 150 kilonewton-meter. All Heron Connect rigs are extremely robust and reliable rack and pinion type machines, and come with an air-conditioned control unit installed within a 20-foot container together with either of 1 or 2 power packs. 4 basic types of drill rigs are available: frame rig, Series F, trailer rig, Series T, crawler rig, Series C, modular rig, Series M. Depending on the customer's requirements, the optimum solution for any kind of project can be selected from the mentioned equipment. The following computer animation shows the use of a 250-ton Heron Connect trailer rig for a pipeline river crossing. The soil conditions in the example consist of typical alluvial soil, as clay and sand. The drilling alignment is shown schematically. The length is approximately 1,200 meters, with an entry angle of 14 degrees at rig side and an exit angle of 10 degrees at pipe side. On both sides of the river, a limited working area is prepared for the drilling equipment and the pipe works. On the rig side, a small entry pit with a depth of approximately 2 meters is installed. A larger storage pit for the drilling suspension is constructed nearby. The separation plant, a buffer tank, a mixing unit for bentonite, a high-pressure mud pump, and power packs and pipe skid complete the basic equipment on the rig side. Most of the equipment is delivered in standard containers and can be installed fast and easily. The control cabin is placed near to the sheet pile wall, which is needed to anchor the drill rig. For easy transport over long distances, trailer rigs have the ideal layout design. Heron Connect's trailer-mounted drill rigs can be towed by any kind of truck with a standard kingpin and sufficient payload. The drill rig is lifted off the truck using crank-handled joist supports, without needing additional hydraulic power. Then the truck can leave the site. With the hydraulic power supply from the power pack, the front supports are then extended and the axle unit is moved into its park position. The carriage and the breakout unit can then be moved into operational position. Both units are connected via a power chain to the hydraulic, electric, and drilling fluid supply. Finally, the rig is anchored to the sheet pile wall and drilling operations can start. The first non-magnetic drill pipe with drill bit is positioned by the crane and connected with the carriage. The drill bit is selected according to the expected geology. In this case, it's a tricone bit with 3 cutters for soft to medium ground conditions. It's pushed forward into the entry pit while rotating constantly. A pipe handling crane grabs the pipes out of the pipe storage and lifts them up to the rig to connect them with the already existing drill string. One after another, the pipes are connected and pushed into the ground. The pipes have conical threads for easy makeup and break of connections. If drilling straight, the drill bit rotates constantly at high revolution. The bentonite suspension is pumped through the drill string to the nozzles in the front of the drill bit, hydraulically cutting the soil in front. There, the drilling mud mixes up with the soil and flows back through the annulus between drill pipe and borehole to the entry pit on the surface. From here, the bentonite cutting mixture is pumped to the separation plant. This unit separates the cuttings from the slurry, and the cleaned fluid is transferred to a buffer tank. Fresh water from the river is mixed with bentonite and added to the mud cycle. Now, the high-pressure pump takes over, pumping the drilling fluid along the surface hoses to the carriage, down through the drill rods and back to the drill bit in the ground. Installed behind the drill bit is a so-called bent sub with approximately 1 to 2 degrees deflection. When the rotation of the drill string stops, the bent sub faces in a certain direction, which is adjustable from 0 to 360 degrees. If pushed further, the drill bit will follow this direction and consequently create a curved alignment in the ground, in line with the project design. The inclinometer in the driller's console shows the working direction of the drill bit in the ground, the so-called tool face. This information, together with the actual azimuth and inclination, is generated by the steering tool. This tool is placed within the first drill rod, located directly behind the drill bit. The references to provide the additional information are the Earth magnetic field for the azimuth and the Earth gravitational field for the inclination. Together with the drilled length, a computer system can calculate the actual position of the drill bit in the ground, enabling the driller to carry out necessary corrections to the alignment by adjusting the tool face on the drill bit prior to further advancement. The driller and the surveyor work inside the air-conditioned control cabin. The large windows allow an excellent overview of the drill rig and job site. When the drill bit punches out on the other side of the obstacle at its predetermined position, the pilot hole is completed, and the drill bit, as well as the anti-magnetic drill pipe with the steering tool, is disconnected from the drill string. In order to enlarge the pilot hole to a larger diameter, a reamer is connected with the drill string and then pulled back through the borehole by the drill rig. Depending on the soil conditions, different types of reamers like barrel reamers, fly cutters, and hole openers are available to achieve optimum drilling progress. All reamers are equipped with nozzles and cutting tools in order to cut the ground both hydraulically and mechanically. The HDD rig pulls back the drill string to the entry position. For each drill pipe which is pulled out on the rig side, a new drill pipe has to be connected to the drill rig string on pipe side. During the reaming process, the entire drill string is inside the borehole. For a safe makeup and breakout of the drill pipes on pipe side, the Heron Connect mobile breakout unit takes care of both the drill pipes and the job site personnel. The breakout unit ensures safe operation up to the required torque. Either the unit is installed in the frame as shown, or it's lifted by equipment similar to an excavator. In both ways, it's driven by a small standalone hydraulic power pack. Depending on the desired final diameter of the borehole, several reaming passes may be necessary. During the reaming process, the drilling fluid with the cuttings returns to both sides of the crossing. After completing the reaming process, the pullback operation can be prepared. The pullback can be done by using the rig only. The prefabricated and tested product pipe is positioned on pipe rollers behind the exit point on pipe side. In order to match the exit angle, the first part of the product pipe is lifted into a suitable catback or overbend to avoid buckling when pulled into the borehole. The pull head of the product pipe is connected via a so-called pullback assembly, consisting of swivel, U-joint or shackles with the reamer and the drill string. Consequently, the HDD rig on rig side starts pulling back the product pipe into the borehole by removing drill rod after drill rod. Finally, the product pipe reaches its position in the ground. Additional force for the pullback can be achieved by using the Heron Connect pipe thruster. The annular clamping unit of the pipe thruster is opened on one side to install the unit around the product pipe. The clamping plates of the unit are lined with special rubber and have a sufficiently large contact surface to the pipe. This means that the laborious threading of the pipeline can be avoided. This powerful device increases the versatility of the HDD method, allowing even longer pipelines with large diameters or under difficult geological conditions. The pipe thruster can recover even jammed or defective pipelines with its thrust and pulling forces of up to 750 tons. When using the Heron Connect Direct Pipe or Pipe Express method, the pipe thruster is always part of the system equipment. The pipe thruster is anchored at the pipe side, in front of the exit point of the borehole, and supports the HDD rig during pipeline installation. Additionally, it pushes the pipeline toward the rig side. Thus, the forces acting on the pipeline are applied better. Two axially arranged hydraulic cylinders of the pipe thruster exert their variably adjustable force on the product pipe. The usable pipeline diameters vary from 8 to 60 inches, simply by changing the clamping plates. The trenchless HDD technology is an environmentally friendly, fast, and cost-effective method to install pipelines under obstacles. With its full-service tunneling, Heron Connect supports rapid construction progress and creates project-specific service packages that include all services required on site. A global network of subsidiaries, affiliated and associated companies working in related fields allows us to provide advice and comprehensive services around the world, always, everywhere.